functional groups are just a collection of bonded atoms, and what they do is a functional group acts the same regardless of the rest of the molecule and its structure. So if I have a particular functional group, like this phenyl ring here, right? A phenyl ring is a 6-membered ring of carbons, and there's double bonds in every other position, and there's hydrogens on the outside. So a phenyl ring is C6H5, right? I see 1, 2, 3, 4, 5 hydrogens, and I see another bond out, right? Another functional group is a carboxylic acid. You see C, O, H, and O. So a carboxylic acid often gets abbreviated COOH. That's another type of functional group. Whether I have a carboxylic acid like this on this molecule or on a different molecule, carboxylic acids tend to act the same way no matter what kind of molecule they're attached to. Phenyl rings tend to act the same way no matter what kind of molecule they're attached to. And that's important. Functional groups mean that I can take advantage of those properties. If I need a molecule with a particular property, I start thinking, hey, what functional group could I use to make that start working? And this really comes in handy in another chapter when we start talking about drugs and drug design. So there's a few sample functional groups that you're going to see on some of our polymers here. One that we're really interested in is the hydroxyl functional group, which is just an OH, right? So O bonded to H, and then the oxygen's bonded somewhere else. There's also a carboxylic acid. It's different from a hydroxyl, right? Hydroxyls are OH, and then there's something else going off in the distance. Carboxylic acids are COOHs. What about another one? There's an ester that's very, very close to a carboxylic acid. That's COOC, and that C will start going elsewhere too. Right? That's a chunk of a molecule. That's a functional group. Esters tend to act the same way. And in fact, esters are the molecules that have smells. You can recognize esters if you... You can recognize esters if you look at labels on some of your foods or some of your shampoos, for example, because they'll always end in 8s. And those 8s are what give your food their nice smell or your perfume their nice smell. Another functional group that you might see is an amine. Amines look like, remember our molecule ammonia, NH3? Amines look like that, except that one of the hydrogens is something else. Similarly, there's an amide functional group, and amides are CONH2, right? So if you see an NH2 next to a CO, you've found an amide. And lastly, there's that phenyl ring that we were talking about. Phenyl rings, this is just another way of drawing it. A phenyl ring is a carbon, actually 6 carbons, bonded in a ring, 1, 2, 3, 4, 5, 6. And there are double bonds in every other position. And there are H's. And one of those just goes somewhere else. That's a phenyl ring. These are functional groups, and we're going to get practice in this chapter and in the next couple of chapters picking these guys out of molecules. So let's start taking a look. I want to review functional groups very quickly, right? A functional group was a collection of bonded atoms, and that functional group acts the same no matter what kind of molecule it's in. A carboxylic acid in a atorvastatin acts pretty similarly to the carboxylic acid in acetic acid, and I can do similar things to it. We're going to get some more functional groups in Chapter 10, as you've seen as you've been reading, and a couple of them are alkanes, right? An alkane is a straight chain of CH groups. So if you see a whole bunch of C's and H's together, you've found an alkane. And this molecule still has a carboxylic acid in it, COOHs, right? Let's look at these molecules below. Do any of these guys have alkanes or carboxylic acids? If I look at the molecule in the lower left-hand corner, sure, I see COOH. This one has a carboxylic acid. What about the upper one on the right? I don't see any COOHs, so there's no carboxylic acids in this one. And down here, I see a COO, but there's a C here, right? There's no H there. So this is not a carboxylic acid. You want to be able to identify functional groups. I will give you the tables, and let's take a look at those real quick. Right? If we look at functional groups in tables, this is table 10.3 from your book. I will give you a graphic of this in all your exams. I am not looking for you to memorize functional groups. You notice that the hydroxyl that we're familiar with from before is present in our table. There's a few more on this page, right? There's ethers that are COC. So if you see an oxygen that's off by its lonesome in a molecule, you found an ether. Aldehydes, right? Aldehydes come on the ends of molecules because they end in CHO. Ethers come in the middle. Ketones have to come in the middle of molecules as well, right? C with carbon or with double bonds. On the other hand, this is the rest of table 10.3. It's just easier to split this up so you can see it better, right? Carboxylic acids we've seen before, esters we've seen before, amines and amides we've seen before, right? These are our COO somethings. So COOH, COOC, CONH. Our amine is the oddball, right? Amines are like ammonia. I will give you this table. I want you to recognize what's going on. Go look at the functional groups in atorvastatin. I've got the skeletal drawing here, and it's easy to tell, right? I had started circling these before, and you can see that there's a carboxylic acid, right? You're used to seeing carboxylic acids now. I hope that you can pick those out pretty well. There are a couple of hydroxyl groups too, aren't there? OHs are hydroxyls. There's an amide, right? I see a CONH2 right here. And you could, in theory, you could almost classify that as an amine, but I'm not going to make you do that. All right? These three, the amides, the hydroxyls, and the carboxylic acids, are the ones that I want you to be able to see. Let's identify functional groups in some more molecules. These are all drug molecules, or molecules that occur naturally in nature. This one here is capsaicin, and capsaicin is what gives peppers their spicy kick, but it's also used as pain relief because if you think about it, right, you eat a really spicy pepper, your tongue goes very numb, and you can't feel anything for a while. Capsaicin does the same thing if you apply it as a topical ointment, as a lotion or something like that. It can help with pain relief that way. Let's look at capsaicin here, though. I see an oxygen all off by its lonesome. There's an ether in capsaicin. I see an OH, so I see a hydroxyl. I see a phenyl ring. I see CONH2, so I see an amide. And I see a big chain of alkane. Sorry, there should be an L in there, right? This is what you want to be able to do. Look at a molecule, use the table, and pick out the functional groups. What about this one? This is the antibiotic penicillin. And if I look at penicillin, I see R. R actually means that it's C and then something else, right? Going however long. So this is an amide. Over here, I've got a carboxylic acid. And over here, it's not quite a CONH2 because I'm missing my ends. So this guy right here is a ketone. Let's look at another molecule. This is oseltamivir. Oseltamivir is the active component, the drug component in the medicine Tamiflu, which they'll give you sometimes if you've had the flu virus for a short period of time. And if I look, hey, there's an oxygen all by its lonesome. There's an ether in Tamiflu. Over here I see a COOC, so there's an ester in Tamiflu. Here's an amine. And here I see CONH. That's an amide. This is how we identify functional groups in molecules. We look for the pieces. We use that table to help us find that out.